everybody, Sorbeaten here, and welcome back to another past paper practice video. In this video, I will be tackling some bearings questions, so let's head straight into the first question. So the question says, two ports E and G are on level ground, 245 km apart. The bearing of E from G is 302 degrees. A ship is anchored at F, some distance away from G, on a bearing of 228 degrees. Angle EFG is equal to 52 degrees. The information is shown in the diagram below. So it says on the diagram above, so it's basically explains what's going on here. So on the diagram above, insert the angle 228 degrees, the bearing of F from G. So the bearing of F from G, so from G, that means we are going from G, so the north line is already drawn up, and we go 228 degrees, so here will be 228 degrees. And this would be the bearing of F from G, as easy as that. So next one says, determine the value of angle FEG. So the angle FEG would be this angle here. So let's see if we can determine that angle. So they also told us that the bearing of E from G, the bearing of E, which is here, from G, which is here, is 302 degrees. So the north line is already drawn, so we go all the way around to E would be 302 degrees. So we know this piece that we just found here, so let me use another color. So we know from here to here is 228. So we know this remaining piece would be 302 minus 228, which would be 74 degrees. So we know this piece here would be 74 degrees. So they want us to determine the angle of FEG, which would be this piece here. So we see FEG would simply be equal to, so we know the number of degrees in a triangle is 180, so it's 180 subtract, and this would be 52 plus 74. This would be 180 subtract 52 plus 74. So it subtract 126, which would give us 54 degrees. So angle FEG, so we can say angle FEG is equal to 54 degrees. So the next question says, calculate GF, the distance the ship is from the port. So GF would be here. So they want us to find that. So let's look at what we are given. So we see we are given this here and this angle. And we are given this angle that we just found that we want to find here. So we see we can use the sine rule. So the sine rule says, so let's see, you know, if here is E, here would be common E. If here is F, here would be common F. And if here is G, here would be common G. So the sine rule says, in this case, we want to find E. So it is E over sine E is equal to F over sine F. So E is what we want to find. So we know E would be GF over sine E. So sine E would be 54. So this is sine 54 is equal to F, which is 245 over sine F, which is sine 52. So we can do some cross multiplication and then solve. So we do some cross multiplication. So we know GF multiplied by sine 52 will be equal to sine 54 multiplied by 245. So we can say 245 multiplied by sine 54. So we know GF would be equal to 245 multiplied by sine 54, all divided by, since this is multiplying, take 2 to divide, all divided by sine 52. So we can punch all of this in our calculator. And we'll have, so 245 multiplied by sine 54. And then we divide that answer by sine 52. So hence this will be equal to 251.5. So we can say GF is equal to 251.5 approximately. We rounded this off. So GF is equal to 251.5 km. And this will be the distance GF. So the next question says, indicate the point H on EF such that GH is the shortest distance from G to EF. So we know we want the point H on the line EF, which would be this line here. So they said that GH, which is from G to some point on this line, is the shortest distance. So we see the shortest distance would mean when it is perpendicular to this line. So we can draw in a perpendicular line here. And we can call this here H. So when it's perpendicular, that would mean that would be the shortest distance from G to H. Reason being, because the line doesn't have to bend and go all the way here. When it's 90 degrees perpendicular, it's very short, the shortest distance. So that is how we indicate that. So that goes to 1 mark. And the next one, they want us to determine the distance GH, which would be the same thing that we just found. So there are many things we can do to find GH. So we know we're dealing with a right angle triangle. So what we can do, we know the distance here, and we know we want to find here. So let's label this triangle. We're dealing with a right angle triangle. So we know EH would actually be, let's use this angle. So EH would be the opposite. And here would be, since it's opposite the right angle, it would be hypotenuse. And that's all, this is what we need. So let's see. Some old horses can always hear their owner's approach. So once we're dealing with the right angle, we know we're dealing with the trig ratios, which would be sine, cos, and tan ratio. So let's see which one has the hypotenuse and the opposite. So we see sine. So we can say sine theta, in this case, is 54, is equal to the opposite, which is what we want to find, which is GH over the hypotenuse, which is 245. So we can say this is dividing, take double multiply. So we can say 245 multiplied by sine 54 is equal to GH. So GH should be equal to so we punch it in our calculator. GH should be equal to 245 multiplied by sine 54 would give us 198. 198.2 km. All right, so we can say, therefore, GH is equal to so we can say, therefore, GH is 198.2 km. So GH is equal to 198.2 km. And with that, this has brought me to the end of this video in which I tackled some bearings questions. And I trust that this video brought out some of the concepts in bearings, and I want you to use these concepts to answer questions like these to be fully prepared for the exam. So keep practicing, and I'll see you in the next video. Take care.